Okay, the next one, example 21. Two blocks of mass 3.5 kg and 8 kg are connected by a massless string that passes over a frictionless pulley. The inclines are frictionless. Calculate the acceleration of each block and the tension in the string. So we are given two blocks with mass 3.5 and 8 kg. Okay, as you can see here, they are connected by a string, okay, over the massless, the frictionless pulley. So this pulley is frictionless. Okay, now we want to calculate the acceleration of each block and the tension. Okay, again, because they are connected by the same string, okay, they will move in the same direction with the same velocity and acceleration. Okay, maksudnya acceleration dekat sini adalah acceleration for the whole system since they are both connected with the same string. So, sama juga tension pun akan jadi value yang sama sebab string yang sama. Okay, now we need to determine the direction of the acceleration. Okay, kita tengok dekat sini the mass here. Okay, let's label this one M1 lah. So, this one M1, this one M2. Okay, so now as you can see M2 here is the mass M2 here is bigger than M1, so obviously okay, dia akan bergerak ke bawah. So this whole system will be going to this direction. So maksudnya acceleration here will be like this, and this one pun akan jadi macam ni. Okay, since dia adalah inclined plane. So now kita sudah tentukan direction of acceleration. Dia akan bergerak macam ni dan macam ni. Okay, next one we need to draw the FBD. Okay, macam biasa draw FBD, identify dahulu. So this one ada weight force going downward, and then normal force, and then the surface here is frictionless, so we don't need to include the friction force. And then akan ada satu tali here, so satu tension force which is away from the object. So sama juga untuk this one. And then normal force, and then the tali, the tension force. Okay. Okay, now we transfer them into FBD here. Okay, so untuk inclined plane, we usually will draw X and Y axis. So kita label dahulu ni adalah Y, ni adalah X axis. Sama juga this one adalah Y, this one will be X axis. Actually, I just follow this one, the plane. So plane untuk yang M1 ni kan dia macam ni. So it will be like this. And then this one pula dia macam ni. So will be like this lah. Okay, so masukkan each of the forces, and then T is on X axis. Tension dekat sini adalah on horizontal, so dia adalah on X axis. So this one will be the normal on Y axis. And then don't forget the angle here. Okay, angle ni dekat sini adalah dekat sini, 35. Okay, so next one, this one sama juga, it will be like this, and then T will be going here, and then this one will be the normal force, and the 35 degree will be here. Okay, kalau kamu notice sebenarnya kan, bila inclined plane ni kita akan dapat angle tu, dia sebenarnya angle tu dekat Y axis. Okay, kalau kamu perasan selama ni lah kita buat example untuk inclined plane. Okay, angle tu selalunya dia dekat X axis actually. So kalau kamu susah mau nampak, mungkin boleh ingat macam tu lah. Okay, so label lah this one M1, this one M2. Okay, so next one, after we draw the FBD, kita akan draw the table. Do we need to draw the table? Actually, we don't need to draw the table. Okay, satu kenapa? Sebab kita minta dekat sini actually we want acceleration and tension. Di mana acceleration kita adalah on the x-axis only. Okay, acceleration macam ni kan? Dia adalah this one, horizontal. So this one here. Dan tension pun dekat x-axis saja sama. Okay, so kalau sama actually you don't need to draw the table. Okay, and then masukkan dekat sini the direction of acceleration. Okay. So now just keluarkan untuk x-axis sahaja, x component. Okay, kita tengok the first one dahulu. Di mana t follow the direction of a, so t akan jadi positif. T akan jadi positif. And then okay, ingat dekat sini W1 kita kena resolve into X and Y component. So W1 kat sini akan jadi WX, kat sini akan jadi WY. So we don't need WY sebab kita hanya akan tengok dekat X component sahaja. So WX di sini akan jadi negatif sebab opposite direction with A. So negative W1 sin 35. Okay, jangan confuse lah. Kena ingat WX sama dengan W1 sin theta. And then WY akan jadi W1 cos theta based on this one here. Okay, so Miss just masukkan sajalah dekat sini terus. And then akan dapat M1 which is sama dengan 3.5 A. So here kamu boleh masukkan W1 di mana W adalah sama dengan mg 3.5. Okay, W1 sama dengan m1g 3.5 times 9.81 sin 35 equal to 3.5a. So akan dapat t minus 19.694 equal to 3.5a. So t equal to 3.5a plus 19.694. So first equation. And then second equation kita akan dapat daripada M2. So fx for M2 pula. Okay, so untuk M2 sama juga. Kita ada dekat sini adalah Wx, kat sini adalah Wy. Okay, so Wx follow acceleration. So Wx akan jadi positif, t akan jadi negatif. So Wx terus masukkan, dia akan jadi W2 sin 35. Okay, sama juga ni, macam ni. Cuma now we are using W2, so this one kamu ubah W2 minus t equal to M2 sama dengan what's the mass? 8a. So W2 boleh masukkan 8 darab dengan 9.1. Okay, W2 is equal to M2G sin 35 minus T sama dengan 8A. So kamu akan dapat 45.014 minus T sama dengan 8A. T sama dengan, so you will get the second equation. Okay, so dapat dua equation, boleh solve macam biasa. So kamu boleh dapat A is equal to 2.20 meter per second squared. Okay, so now we can find the value for the tension. So from equation 1, okay, T is equal to 3.5, gunakan value for A. So you will get T will be equal to 27.39 Newton. Now let's look at example 23. A student of mass 40 kg stands inside an elevator on a weighing scale. Calculate the reading of the scale if we have 4 different situations given here. Okay, so basically we have a student with 40 kg mass in an elevator. Now we want to know what is the reading of the scale if we are given 4 different situations here. Okay, before we can look at the situation, let's write down the information. Okay, we have mass 40 kg and then basically objek kita dekat sini adalah the scale because we want to know what is the reading of the scale. So dekat scale ni kita hanya ada 2 forces sahaja, di mana kita ada weight force going downward and then normal force. So this normal force is actually the reading of the scale. This is what we want to find. Okay, so we only have 2 forces, no other forces. So this will be the FBD untuk based on the first information that we are given. Okay, now soalan yang pertama, kita tengok situation yang pertama. Okay, if the elevator moves upwards or downwards with constant speed. Okay, so the keyword here is constant speed. Always remember, if the speed is constant, meaning that acceleration is equal to 0. Okay, acceleration is equal to 0. So tiada acceleration dalam situasi ni. Bermaksud the sum of Fy, okay, since dia adalah dekat Y component kan, adalah sama dengan kosong. Since okay, dia sebenarnya MA, tetapi sebab A adalah sama dengan kosong, so the sum will be equal to 0. So apa yang kita ada dekat sini will be N minus W equal to 0. So the normal force will be equal to the weight force, di mana weight force is equal to mg, right? Mass 40 times 9.81. So it will be equal to 392.4 Newton. Okay, so that's the first one. Okay, the second one, okay, the elevator moves downwards with constant acceleration of 0.5 meter per second square. So now acceleration going downward, like this one. Okay, kita akan keluarkan formula. The sum of Fy is equal to MA. So follow direction of A is positive. So W akan jadi positif, N akan jadi negatif, sama dengan MA. Okay, so N akan jadi sama dengan mg minus MA. So just masukkanlah 40. This one actually you can factorize. So 40 9.81 minus 0.5. So akan dapat 372.4 Newton. Okay, so next one, the elevator moves upwards. Now the elevator moves upwards with constant acceleration 0.5 meter per second squared. Okay, so now direction ni sudah berpindah ke atas. So now acceleration kita ke atas. So soalan C, acceleration still value yang sama, tetapi direction berubah. So keluarkan formula, keluarkan equation, di mana follow direction of A will be positive, N is positive, W will be negative. So kamu akan dapat MA plus MG, di mana M adalah 40, A will be 0.5, G 9.81. So boleh dapat value for N 412.4 Newton. Okay, so last one. Okay, if the elevator cable snaps and the elevator begins to fall. So when the elevator begins to fall, dia sudah masuk dalam mode free fall. So this one is free fall. So ingat lagi dekat chapter tu, kalau free fall, acceleration akan sama dengan negative g. Okay, acceleration dekat y component akan sama dengan negative g. So apabila kita keluarkan equation, so now okay, kita tahu n, dia adalah macam ni kan, it's going downward a. So n will be negative, w will be positive. So n will be equal to w minus ma. Okay, ni masukkanlah terus mg. mg minus ma. But since a adalah sama dengan negative g, so m g minus a kan macam ni sepatutnya. So since a ni adalah negative g, so apabila kita masukkan, dia sebenarnya akan cancel each other. So the reading on the scale will be equal to 0.